Law of cosines works for two types of triangles. First of all, there's side angle side, and this is an example of side angle side here, where we have side fixed, angle fixed, side fixed, and we move this point around, we do a triangle. We do the same thing over here, and they're the same triangle. So side angle side is a congruence theorem from geometry. Now we have side, 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 same idea, three fixed sides. And the only way to get these 2 points B to match up is to swing these around. And when you do that, you get two congruent triangles, which is true for ASA and AAS, which we do with law of sines, whereas it's not true with SSA or AAA, though we do a little bit of SSA with law of sines. So let's go and take a look at the formula now. The formula for law of cosines appears right here. This is your formula for law of cosines right here. A squared is equal to b squared plus c squared minus 2bc cosine of A. And for a right triangle, okay, so this is for any oblique triangle. All right, so let's just draw that in. Alright, this is for an oblique triangle. For a right triangle, your angle A will be 90 degrees, and then your law of cosines just simply becomes the Pythagorean theorem. So you can think of the Pythagorean theorem as a special case of the law of cosines, which appears here. Now, A, B, and C are somewhat interchangeable in that this little a squared, the side length, goes with cosine A, the opposite angle, but you can switch around so that you have, b squared is equal to a squared plus c squared minus 2ac cosine b, for instance. So as long as you remember this formulation of it, you're pretty much good to go. Here's an example if you have side, side, side. And so you have three sides, sides 8, 19, and 14, and you'd like to find out, first of all, angle B will do. So to get angle B, we will set this up in such a way we've got b squared is equal to a squared plus c squared minus 2ac cosine b. We plug in these three numbers, and we solve for cosine b. There's no reason to memorize the formula for cosine b or cosine of any angle. You can always just memorize this one and then solve it algebraically. Put in the calculator, you get b is 121 degrees. There's no ambiguity. There's no ambiguity with law of cosines because SSS and SAS are both triangle congruences. So that's the angle. If you want to continue solving the triangle, finding other angles, you could use the law of cosines again, or you could use the law of sines, though sometimes there are problems with law of sines, as we talked about last class, as far as ambiguity of SSA. As far as getting the area, once you have a side angle side, you can do 1/2 AB sine C. So 1/2 8 times 14, so 1/2 AC sine B, sine of 121 degrees. There's also Heron's formula I'll talk about later, which is another way to get that area, and you can see, well, there's some differences here. I must have rounded off incorrectly. That's SSS. Now let's look at SAS, where you have a side angle side, and you're trying to get the last side. So we've got 46, 60, and 45 degrees. And opposite side squared is equal to 46 squared plus 60 squared minus 2 times 46 times 60 cosine of the angle. You solve it, you get about 42.6. Here's another SSS example. And I'll leave this up there for a moment, but remember you can also get this off of posted web notes. I'll try to remember to post the web notes. If not, I'll leave it here, and you can always pause the presentation. And what I've done here is I've solved the triangle completely, where I've used law of cosines to get angle C, and then I've used it again to get angle B. I could use law of sines there. And once I've got the two angles, well, then I just subtract from 180 to get the third angle. And here is an example of SAS. So I've got side, side, and included angle. Law of cosines to get side C, and then I did law of cosines again to get angle B. Once I've got another angle, I subtract the two angles to get the last angle. I'll solve the triangle. Also in this section is Heron's formula. Heron's formula is another way to get area of an oblique triangle, and this is particularly convenient when you have side, side, side. So S is called the semi-perimeter. You add up the three sides, A plus B plus C, and divide by 2. And then our area K is given by the square root of that semi-perimeter S times S minus A times S minus B times S minus C. So here's the formula for area using Heron's formula is an